This is an attempt to simplify the procedure that I developed wherein we can do the weather modeling and the risk factors simultaneously, or not simultaneously, concurrently. So this is my attempt to simplify and make a little more meaningful, or at least justifiable, what we're going to do here with accounting for rain days. And we're going to do this two different ways. One is by coming up with a rain day allowance and a rain day adjustment. And here's our situation. As before, we cannot run the weather model and risk factors simultaneously. This is a particular limitation in PERT that does make it kind of difficult, because I think all construction schedules need to account for weather, rain days in one way or another, or non-work expected days. One of the problems we have within PERT itself is that it's difficult to assign the weather module, because they use a resource to do that, and it's kind of difficult to assign a global resource to an activity once you're within the weather module. And we still have our 600 activity for your construction project, and again, weather is a significant impact. Now I have, and I'll show you this when we get to the spreadsheet, but I have reduced the impact of weather here, because I've basically said any rain day now becomes any day with precipitation greater than 2/10 of an inch, or 5 millimeters. So the first time the allowance is pretty straightforward. We're going to create a weather allowance activity, and this is done several times. In this particular case, we're going to use the rain day model for the likely value for the planned duration. Then we're going to develop range percentages for these things, for the min-max durations, from that same rain day model. This is because I'm going to try to use the quick risk template just to keep kind of coherent, and again, to simplify the whole thing. We're going to assign a code and develop the profile in the quick risk template. And this allows us to run it multiple times if we have to. Then we're going to perform the normal schedule risk analysis for risk factors in estimate uncertainty. And then we're going to compare the results with what we are going to achieve via the allowance, and just running the weather module alone without attempting to run risk factors. Okay, this is the eventual procedure that I adopted for the adding an adjustment factor. Again, these are only approximations, but I'm pretty surprised. I'm pleased with the output. So anyhow, we're going to use what I'm calling the PERT-X average of rain days for the rain day model, and I'll explain more what this PERT-X average is when we get to the Excel spreadsheet. But once we've got that, that's going to give us a duration, and from that duration, new duration, divided by the old duration, we're going to have a factor to adjust the budget hours of all of the activities affected by weather. And in this particular case, it is all activities, since this is a construction schedule here in the Gulf Coast, where everything is performed pretty much outside. Then later on, we will take this new schedule, and we're going to perform a normal schedule risk analysis for risk factors and estimate uncertainty, and we're going to compare the results. I was pleased with the output from this, but again, this is after several trial and errors, several scenarios. And it's only an approximation, though I think it's a fairly good approximation, that's going to allow us to account for weather and still to use risk factors. So let's move now to the Excel spreadsheet, and I'll show you a little more clearly what I meant. Okay, this is where it begins. And I would suggest you use this, the weatherbase.com, that gave me the most relevant data that I thought I could use, and most current. And so in this particular case, I focused on the number of days in which we had rain in excess of 2/10 of an inch. And these are the average number of days that we did that. And once I had that, then I constructed a worksheet. And with this then I just subtracted the number of Saturdays in that particular month to come up with a likely date. And then from that likely date, I subtracted two days for the minimum and added 2 days for the maximum. And then this was converted into a work table. Once I had the work table, then I had everything I needed to fill out my import template for the weather module. So this is essentially turning all that information into something usable. And so if we take the range from the 1st of July 2013 to the 25th of August of 2017, that's 76 days, which gives us then an expected finish date if we encounter the expected rain of 9 November of 2017. And with that range then is, we can have as little as 15 days or as much as 173 days. So the percentages on that are 20% and 228%. And this will be important when we do the weather template for the time when we do actually do the check on this thing, which will be the populating the weather module. But after a couple scenarios, I came up and finally decided on what they're calling PERT X, which is the PERT value for the extended range. And the extended range is the number of days, rain days that we're going to encounter in the period between the 1st of July 2013 and the 9th of November of 2017. And then, of course, you see the min and the max for those. But the only thing we're particularly interested in here is going to PERT value on the on this range here, if you will, because once we put in an allowance, we no longer are able to account for variability. This is the closest I can come. And again, the PERT formula is fairly well understood, and it's essentially triangular. So I think it's a reasonable approximation. So we will take this 85 days, add that to our existing calendar, which in this case had a elapsed time of 1,516 days. And we're going to add the 85 to that, and then we're going to divide by the 86, and we come up with a factor of 1.054. And just something to remember for later on. Okay, I'm going to show you 3 different reflections here. And the first one is in essentially our base case, or check on the output that we're going to get from the other 2. This is the normal way I would populate a weather module, or try to use the weather module. And that's by adding an additional resource here, which is LC, which is a dimensionless resource. It has no value whatsoever, and it's just there as a way to activate the weather module once it's in PERT master. So what we're going to start with, that's our basic case there, and that's the August 25th. That's our normal deterministic date without accounting for any weather. But we're going to account for weather, and there's 2 ways we're going to do that. In this particular case, we are going to use the weather allowance. And here what we do is we create an activity. It's going to be 76 days in duration, and this is going to take us to the 9th of November. And this is then what we're going to import into PERT master with the additional ranges that we established in the Excel spreadsheet, as you may recall. So this is one of our scenarios, one of our options. And again, the value here is it's straightforward in that it's easy to identify what the value of the rain allowance is. The drawback, as I see it, is the fact that we don't see the influence of weather on any of our intermediate milestones if we had some. We don't in this particular case, but if we had, weather is basically outside of any of our calculations or considerations. And so it's easy to do, but not necessarily giving you the kind of picture that I think we ought to have, which is why then we come up with the adjustment. And here, what we've done is basically taken the operational date to the 20th November by adding a factor. As you can see in this particular case, it's 1.056 that we would have applied to every activity in here, basically increasing its duration. So this is just one method, or one of two methods that you can use if indeed you want to account for weather and are dealing with risk factors. Not sure that it's the optimal answer, and but until PERTmaster makes it possible to use the weather module and risk factors, it seems to be the only way to do it. So show you now what happens when we're in PERTmaster. Okay, this is what would normally happen when you import the weather module that we have. And the thing you'll notice here is that we've assigned this LC resource here. Under risk, we basically have the weather model. We've already assigned all of our stuff here. It's been assigned to all of our tasks via this resource. This is just to let you know that it's there. And this is what it is. I'll show you the distribution analyzer here in a second. But the other example we had was the weather allowance. And here you see the weather allowance plus its range. Remember the 15 and the 173? So that's been accounted for. Then the weather adjustment is just the new date here. And essentially that's all we're going to do for it. And then this is the by the way, I should mention that I didn't use any risk factors. I didn't bring in risk factors into any of these three because I wanted to compare it to the base case weather. I couldn't have done that if I included risk factors. But both of these, the allowance and the adjustment, it would be possible to run risk factors with these things now as they sit. So, but I just want to show you what happens here when we come up with the distribution analyzer. And so I am just really pleased, especially if we look at the P80 on these things. Very close correspondence, and it's kind of what you would expect here. I think it's rather fortuitous that it turned out this well. I'd like to run this on more plans to find out just how good it is. But I'm fairly happy with it. Okay, in summary, this is what I think are the advantages and disadvantages of both the allowance or the adjustment factor. Now, understand the caveat here is it's only really been tested, validated on one project. It needs more testing before I can say with any certainty that this is working, but it seems to be an answer to a particular situation. This situation here is the need to account for weather and to use risk factors and apply risk factors to our project schedule that already has duration uncertainty or estimate uncertainty in it. So for me, the advantages to the allowance are it's the easiest to create and apply. It's really simple to add that activity. And once you've done that, it's easy to explain and for management to understand what you have done. Now, it also isolates the weather impact, so it's fairly easy, again, for management to understand just how important is weather to the overall successful completion of the project. The disadvantage, of course, is, in my mind, is that the incremental impact of the weather is lost. So interim milestones before the end of the project, there's no way to really determine what their expected finish date might be if accounting for weather. Okay, these are the advantages and disadvantages that I see for the adjustment factor. And it's fairly easy to create and apply. It maintains the incremental impact of weather. But by the same token, it also does not isolate the weather impact, so it's not obvious to anyone that doesn't see the spreadsheet just how important weather is. And because of that, it's not as easy to explain or understand. Given all of that, if I had to choose between the two scenarios, two systems, I would go with the adjustment factor because I think it's more closely models what we're trying to do with the weather module.